Okay, this video is for Learning Target 6, and it's just a continuation of the Learning Target 5 video. So if you haven't watched it and need to, you might want to go back and see the first introduction to geometric sequences. But now for geometric means, you can read the paragraph that kind of introduces them. But we had a trick, if you will, to find arithmetic means, but for this target, it's best if we just don't even attempt to find a quicker way. Let's just try to use the formula a sub n equals a sub 1 times r to the n minus 1 to find the geometric means. Geometric mean is the term in the middle, so the example up here, 6, the term in the middle of 2 and 18 that makes the pattern geometric, times 3 times 3, so 6 makes that pattern a geometric pattern. So in example A, we're looking for the number in the middle here that would make 3 blank 75 become geometric, a geometric pattern. So the first thing is that 3 represents the first term, and the 75 represents the third term. So when we start plugging those into the formula for a geometric sequence, the a sub 1 goes on the right side of the equals. We don't know r, and we won't ever be able to find out what r is unless we're given terms back to back. So 2 terms side by side, that's the only way we can find the r without using this formula the way we're about to. So that leaves us with 2 missing pieces, the exponent n and the term a sub n. Well, 75 being the n equals 3 term gives us both of those pieces of information. When n is 3, a sub 3, which I'm going to erase, a sub 3 is 75. So we can replace the left side of the formula with 75 and the n with 3. And then we let algebra take over. 75 equals 3r squared. And to solve for r, we divide by 3. Divide by 3. So 25 equals r squared. And then it becomes kind of a guessing game. What is the r, the number that you would square to make 25? And most people will immediately say 5. And you're right, r is 5. But if the exponent is even and you're trying to figure out what you could square to make 25, don't forget that you could square the negative 5. Negative 5 times negative 5 would also give you 25. So r could be negative 5 as well. So what that means is this. The missing a2 term that we were trying to find, the geometric mean, a2 is equal to the first term 3 times 5, but it could also be equal to 3 times the r negative 5. So you have the answer 15 or the answer negative 15. Either one of those could be the missing geometric mean for A. And then in B, it's much the same. The only difference is we got fractions to deal with. So the first step, take the geometric sequence formula and start putting in the pieces that were given. A1 is negative 2/3. We don't know r, but we were given the third term again to be negative 6/25. So just like last time, we can put the 3 in the exponent where n is, and we can replace a sub 3 with the fraction negative 6/25. So negative 6/25. Now, while I would like for you to be real comfortable with fractions and be able to do this in your head or use the rules of fractions to divide this next step, because this is going to become r squared, we're going to have to solve for r squared like we did on the left side to divide by negative 2/3. So while I would like you to be able to do that in your head or using the rules of fractions, at this point I definitely want to show you that the calculator you purchased has this ability and can even give you the answer in a fraction form. So you start by typing in the fraction negative 6 divided by 25. You type a fraction in by using parentheses, and then divide that by the fraction negative 2/3. So open parentheses, negative 2 divided by 3. Enter. You may not know that decimal as a fraction, but if you hit the button Math, first option fraction, it's going to take your answer and turn it into a fraction. Hit enter one more time, and the answer is 9/25, meaning 9/25 equals r squared. So what would you square? That's r. What would you square to make 9/25? Well, you would, let me make that a little bit bigger. you would, to make a fraction, you need to square a fraction. So thinking about that, what would you square to make a 9 in the top of the fraction? Well, you'd square 3. And what would you square to make 25? You'd square 5. So r could be 3/5. But since it's an exponent 2, we want to check to see if negative 3/5 would give us that as well. And what is a negative 3/5 times a negative 3/5? It's going to be positive. Negative times a negative makes a positive 9/25. So it's also going to work as well if r is negative 3/5. So just like last time, our middle term, a sub 2, can be two different answers. The first, negative 2/3 times the r 3/5. You'll notice the 3's will reduce to 1 on the diagonal there, and you get the answer negative 2/5. The second answer, negative 2/3, the first term, could be multiplied by the other r, negative 3/5. And here the 3's again will cancel, leaving you with 1/1. But now you have negative 2 times negative 1 in the top, so positive 2, and 1 times 5, 5. So you have two options for the geometric means, negative 2/5 and positive 2/5. And I should have done this on the last problem, but I want to go ahead and do this on this problem. Just to put your mind at ease, you can always take your first term times your r, 3/5, and get the middle term, negative 2/5. But take it one more step and multiply by that r again, 3/5, and make sure you get the fraction that they gave us, negative 6/25. And we do. So then we are feeling a little bit better about the answer we got because we got a negative 6/25 as our third term using that r. So, and you can do that also with the negative 3/5 r and get the same answer, negative 6/25. All right, last two. In C, we're given the first term and the fourth term. In D, we're given the first term and the fifth term. So the only thing that's going to change in our process of using the formula here and here is that the n that goes with the fourth term or the fifth term, it's just going to be a little bit different. So I'm going to set these both up to start with. So the first step, I'm going to focus on C. It equals first term 2 times r to the blank minus 1. And 2/27 is the fourth term. So when n is 4, the term is 2/27. So we'll put a 4 in the exponent and the fraction 2/27 here. And I also want to set D up, so we're going to focus on D now, focus on the problem D, and see how it looks. It's going to be similar. We're going to start with equals 6 for the first term, r to the blank minus 1, and the 96 is the n equals 5 term. So 5 goes here, and 96 goes there. So you can kind of compare the two and see that, okay, we're putting the first term where it goes, and then we're putting the fourth or fifth or whatever term where it goes on the left side, and putting the 4 or 5 or 6, the n value, in the exponent that goes with it. All right, so for both of these, you let algebra take over to solve. 2/27 equals 2r cubed. So we're going to divide by 2 to both sides. I would like, again, for you to be able to do this in your head, but just in case we need to, 2/27, parentheses, 2 divided by 27, divided by 2 is really multiplying by 1/2. Yeah, dividing by 2 is multiplying by 1/2. So those 2's are going to cancel, and you're going to be left with 1/27. But again, if you're not comfortable doing that in your head, you take 2/27, the fraction, divide it by 2, hit math, enter, enter, and 1/27 is your r cubed. And then it becomes the guessing game, 1/27. What would you cube to make 1/27? Well, some fraction. You would cube a 1 to make a 1 in the top of the fraction. And if you don't know your perfect cubes, you can make a list. 2 cubed is 8. 3 cubed is 27, which is the one we need. 4 cubed is 64. So, but to answer our question, what would you cube to make a 27? You would cube a 3. So r is 1/3. Now this exponent is 3. So if we attempt to make the 1/3 negative and raise it to the third power, negative 1/3 times negative 1/3 times negative 1/3, whoops, negative 1/3 to the third power is going to give us a negative 1/27, and that's not the same thing. So r cannot be negative 1/3. It doesn't give you the 1/27 that we were looking for back here. So that means there's only one r and it's 1/3, meaning there's only one set of A2 and A3, one set of missing numbers. And you find them by multiplying by the r 1/3. So take your first term, 2, times the third, and you get 2/3. Then take your second term, once you've got this term is 2/3, multiply by 1/3 again. So 2/3 times 1/3, multiply 2 times 1 in the top, 3 times 3 in the bottom, so 2/9. Just for good measures, multiply 2/9 times 1/3 again, 2/9 times 1/3 gives you 2/27, which is what we were looking for. So we feel good that those are the two missing geometric means. All right, now for the last one, I'm not really going to explain it. I'm just going to show it. And if you have any questions, feel free to come talk to me in class about it, but I'm going to just show the work. If you want to pause the video right now and try D on your own, I would suggest to do that. But here goes D. Two to the fourth. Just trying to figure out what gives us 3 to the fourth gives 16, and it's 2. But since it's even, r can be 2, but I want to see if negative 2 is going to work. And it is, because a negative times a negative times a negative times a negative, 4 negatives is going to make a positive 16. So we've got 2 r's, so we're going to have 2 sets of answers. First times 2, 12, 24 times 2, 48. So one set of answers, 12, 24, 48. Now if we multiply by negative 2, times negative 2, times negative 2, times negative 2. Well, 6 times negative 2 is going to make negative 12. Negative 12 times negative 2, positive 24. 24 times negative 2, negative 48. And then negative 48 times negative 2, we're back to the 96. So there are 2 possible sets of geometric means.